Hey science fans! Ever wondered what would happen if we mixed every acid, from the strongest lab acids to the ones in your kitchen, into one giant container? Would it be a scientific breakthrough, or just a recipe for disaster? Let's find out, safely, in our imaginations. Remember, this is a thought experiment only. Mixing unknown chemicals, especially acids, is extremely dangerous. Our goal? To explore the wild world of acids, all from a safe distance. So buckle up. We're about to dive into what makes acids tick, and what might happen if we combine them all. Ready to imagine the sights, sounds, and even the smells. Without any risk, let's get started. So, what exactly is an acid, and why do they play such a big role in both science and our everyday lives? You've definitely tasted acids before. Think of the sharp tang of lemons, the bite of vinegar, or even the fizz of soda. That mouth-puckering sensation? That's acid at work, giving foods and drinks their signature sourness. But what makes something an acid, chemically speaking? Acids are special molecules that have the ability to donate protons. Tiny, positively charged hydrogen ions, also known as H+ ions. This is what sets them apart from other substances. This unique ability to give away protons makes acids highly reactive. When you see bubbling, fizzing, or even heat being released in a lab experiment, chances are acids are involved. When acids encounter other substances, especially bases, they eagerly hand over their protons. This exchange can break down molecules, release energy as heat, and sometimes even produce gases that bubble up and escape. Not all acids are created equal though. The easier an acid gives up its protons, the stronger it is. Some acids, like hydrochloric acid, are very strong, while others, like acetic acid and vinegar, are much weaker. To measure how acidic something is, scientists use the pH scale. This scale runs from 0 to 14. 0 is extremely acidic, 7 is neutral, and 14 is very basic or alkaline. The lower the number, the stronger the acid. For example, battery acid is incredibly strong, with a pH around 1. It's so powerful it can burn skin and corrode metals. Lemon juice, on the other hand, is much milder, with a pH of about 2 or 3. It's still sour, but safe enough to eat. Even soda, which tastes sweet, is actually acidic, with a pH between 3 and 4. That's why it can tingle your tongue and even clean a penny. So, acids are more than just sour. They're proton-donating, highly reactive, and found everywhere from your kitchen to the chemistry lab. Their willingness to give up those H+ ions is what defines their chemical personality and determines how they interact with the world around them. Understanding the science of acids is the first step before we even think about mixing them together, because when acids get involved, things can get very interesting, very fast. Let's meet our acid contenders. Today, we're diving into the fascinating world of acids, from the most dangerous chemicals you'll find in a lab to the everyday acids hiding in your kitchen. Each acid has its own personality, its own strength, and its own story to tell. So, buckle up as we explore what makes each of these substances unique, and why some are safe to taste, while others are best left behind thick safety glass. First, let's talk about the strong acids. These are the heavy hitters. Sulfuric acid, found in car batteries, is so powerful it can eat through metal and cause severe burns. Hydrochloric acid, which your stomach uses to break down food, is strong enough to dissolve many metals. And then there's nitric acid, a key ingredient in fertilizers and explosives, known for its intense reactivity and ability to turn proteins yellow. What makes these acids so intense? When you add them to water, they give up their protons, those tiny hydrogen ions, completely and without hesitation. This total release of protons makes them highly reactive, causing dramatic chemical reactions that can be both useful and dangerous. Now let's meet the weak acids. These are the acids you're more likely to encounter in your daily life. Acetic acid gives vinegar its sharp tang, citric acid brings the sour punch to lemons and limes, and carbonic acid is what makes your soda fizzy and refreshing. Unlike their strong cousins, weak acids only partially let go of their protons when mixed with water. This means their reactions are much gentler, less aggressive, and often safe enough to taste or touch, though you should always be careful. When you measure the pH of a solution, strong acids flood the water with H+ ions, dropping the pH dramatically. Weak acids, on the other hand, hold back, releasing only a few protons and keeping the pH higher. This difference is what separates a dangerous chemical burn from a zesty lemonade. Think of it this way. Strong acids are like eager givers, handing out protons to anyone who'll take them, while weak acids are more reserved, keeping most of their protons to themselves. This crucial difference shapes how they behave in every experiment. So when we imagine our mega mix of acids, knowing which ones are strong and which are weak helps us predict the kind of chemical chaos that might unfold. Will it be a gentle fizz or a wild eruption? Some acids, like the ones in fruit, you can safely taste. Others, like those in batteries or cleaning products, you should never touch without protection. The world of acids is full of surprises, some delicious, some dangerous. But whether strong or weak, each acid plays a unique role in our ultimate experiment. Their differences set the stage for a spectacular display of chemistry in action. The combination of strong and weak acids is about to create a mix that's unpredictable, exciting, and maybe even a little bit explosive. Get ready for some wild chemistry. Let's see what happens next as we bring all these acids together and watch the science unfold. If we were to mix every acid, we'd need a super secure, high-tech lab, definitely not your kitchen. Picture stainless steel surfaces, powerful fume hoods, and top-tier protective gear face shields, acid-resistant gloves, and full-body suits. Emergency showers and eye wash stations everywhere. Safety is everything. The container? Not glass. Some acids can eat through it. We'd use something ultra-resistant like Teflon or special ceramics. The lab would be packed with sensors and remote controls to monitor temperature and pressure. We'd add acid slowly, ready to cool things down if needed. And of course, a solid emergency plan. This is all about observing and learning, safely, even in our imaginations. Ready for the big mix? The big moment is here. We're about to combine some of the most powerful acids known to science, sulfuric, nitric, and hydrochloric, right into our ultra-resistant laboratory container. Each of these acids is a chemical powerhouse on its own, but together, they promise a reaction that's anything but ordinary. As the liquids pour in, you can almost feel the anticipation in the air. This isn't just a simple mix. It's a collision of some of the most reactive substances you'll ever find in a lab. The very first thing you'll notice? Heat. Lots of it. When strong acids are mixed, they don't just sit quietly together. The process releases a burst of energy, causing the solution to heat up rapidly. Sometimes you'll even see steam rising as the temperature climbs. This is a clear sign that powerful chemical changes are underway, and it's why chemists always handle these mixtures with extreme caution. Inside the beaker, most strong acids are already fully dissociated into their ions, so when they're mixed, you get a swirling soup of highly reactive particles. These ions zip around, bumping into each other, ready to react at the slightest provocation. It's a chaotic dance at the molecular level, and the energy in the solution is palpable. But it's not just a simple mix. Some fascinating chemistry happens too. For example, when sulfuric acid meets nitric acid, they can react to form the nitronium ion, a super powerful oxidizer used in making explosives and dyes. This is a reaction you definitely don't want to happen outside of a controlled lab. Next, we add some weak acids, household names like vinegar, citric acid from lemons, and even carbonic acid, the fizz in your soda. Compared to the strong acids, these are much gentler, but in this environment, they're about to be completely overwhelmed. With so many free H+ ions already floating around from the strong acids, the weak acids barely get a chance to dissociate. Their molecules mostly stay intact, unable to compete in this highly acidic environment. The result? The weak acids are almost drowned out, their usual reactions stifled by the chemical chaos. What you end up with is a dense, unpredictable chemical soup. The solution becomes thick and syrupy, especially thanks to the concentrated sulfuric acid, which loves to soak up water and thicken mixtures. The color might shift, and the texture becomes almost otherworldly. Some acids, like sulfuric, are so strong they can char organic impurities, turning the mixture dark and sometimes even producing a burnt smell. This is a sign of powerful dehydration reactions happening right before your eyes. Nitric acid, on the other hand, can break down and release nitrogen dioxide gas, a toxic yellow-brown fume that adds both color and danger to the mix. If you see a yellow or brown tint, that's the chemistry in action. The final mixture is a wild reactive mess, hot, dense, and full of surprises. It bubbles, steams, and fizzes with new compounds forming and breaking down in real time. Every second, something new could happen. This is chemistry at its most chaotic and unpredictable, a true spectacle of science where control is everything and surprises lurk in every swirl. Would it look cool? Absolutely, it's a mesmerizing display of color, heat, and motion. But would it be safe? Not at all. Only trained professionals in a well-equipped lab should ever attempt something like this. So what else could happen in this bubbling brew? With so many reactive ingredients, the possibilities are endless. Let's keep watching and see what wild chemistry unfolds next. One thing's for sure, mixing all these acids would unleash a storm of gases. Hydrogen chloride gas from hydrochloric acid, sharp and corrosive. Nitric acid can produce nitrogen dioxide, a toxic reddish-brown gas with a choking smell. Sulfuric acid, especially when hot, can release sulfur dioxide, think burnt matches. Add in steam from heat and maybe other gases from side reactions. The result? A thick, acrid, and dangerous cloud. Definitely not something you want to breathe. That's why chemists use powerful fume hoods and treat acids with respect. The smell alone would be a warning. Serious chemistry is happening. Gases are no joke. Handle with care, even in your imagination. Could our mega acid mix explode? Not likely in a Hollywood way, but danger is real. Rapid gas production and heat could cause a violent boil-over or rupture the container if pressure builds. Some acid combos, like strong oxidizers with organics, can explode. If the mix spilled, it would eat through wood, damage concrete, and char anything organic. The heat could make it boil and splatter, spreading corrosive acid everywhere. Even the toughest container might fail under extreme conditions. So while it won't melt to the Earth's core, a spill would be a chemical disaster. This is why such experiments stay in the realm of imagination. Safety first always. There's a real-life acid mix that's legendary, Aqua Regia, Latin for royal water. It's a blend of nitric and hydrochloric acids, famous for dissolving gold, something neither acid can do alone. Nitric acid oxidizes gold, while hydrochloric acid stabilizes the gold ions, letting more gold dissolve. This teamwork makes Aqua Regia a superstar in chemistry, used for refining precious metals. Our megamix? Too chaotic to predict. Some acids might cancel each other out, others could make things even more reactive. Aqua Regia shows that the right combination can do what single acids can't. Science is full of surprises. Sometimes it's all about the mix. Our thought experiment is wild, but real chemistry is even more amazing. Let's keep exploring. Acids aren't just for labs, they're everywhere in your life. Vinegar and salad dressing, acetic acid, lemonade, citric and ascorbic acids, yogurt's tang, lactic acid. Even your stomach uses hydrochloric acid to digest food and kill germs. Sometimes too much acid causes heartburn, but usually it's essential for health. In nature, volcanoes release acidic gases, and acid rain forms from pollutants. Industry relies on acids. Sulfuric acid is used in fertilizers, batteries, and more. Acids clean metals, etch circuits, and power countless processes. From food to factories, acids shape our world. Understanding them helps us stay safe and curious. So, next time you taste something sour, remember, science is everywhere. Keep asking questions.